This afternoon we're out on the Neuse River in North Carolina collecting bed sediment samples. This is part of a large national project that's intended to calculate and determine the concentration and masses of sediment-associated off-continent flux of a variety of chemical constituents. We're sampling the sediment because the sediment is a major carrier for things like trace elements, nutrients, and a number of organic pollutants like DDT and PCBs. Ordinarily we would use suspended sediment, but it would take a very long time to get a sufficient mass of it to work with. So we're using bed sediment as a surrogate, but we're not using the entire or all of the bed sediment. We're just looking at the less than 63 micron fraction. Those samples that we're collecting are representative cross-sectional ones, so that we've collected aliquots as we've gone across the stream bed and composited it so that it represents the entire river cross-section. And ultimately we'll be collecting the same kind of material at 130 river sites all around the coast of the United States, starting in Maine, going to the tip of Florida, going from the tip of Florida all the way over to the Texas-Mexico border, and then from Baja California all the way up the coast of the West Coast and into Washington, because we're also going to collect samples from rivers that discharge into Puget Sound. What's the bottom feel like?
Mud with a lot of clams?
Oh, good.
Or oysters?
Just what I needed.
So Art, what's this you're using to collect sediment samples?
This is a petite ponar, and it's spring-loaded. And what happens is, as long as I keep tension on the line, the spring stays shut because the two bars keep the thing in place. When I hit the bottom, the spring pops out. And then when I pull up, it closes. And that's how I collect the sample.
And about how much of the sediment layer do you get with this?
Well, it depends on the bottom and how heavy it is. If the bottom is fairly soft, we probably go down about 6 to 8 inches. But we're only trying to collect the upper 1 to 2 centimeters. We got something. Well, we got a big clam.
Is there a minimum amount that you need? Or?
Well, we can do the analysis on 2 grams or less, but I want a representative sample. Figure roughly about the point where that post is.
Okay.
And we'll start there. We'll see what the water depth is.
Okay.
So Art, what are your expected results from this study?
Well, we ultimately will come up with a mass of, or concentrations for all the constituents that we're measuring. Right now, approximately 260 megatons of sediment are discharged to the Atlantic, Gulf, and Pacific. And those sediments contain high concentrations of a variety of constituents. Some of them are within normal range, some of them exceed those ranges, but we won't really know until we actually carry out a chemical analysis on them. The information we get from this will give us a baseline level of chemical transport, which can be used in part to assess climate change effects or changes from climate change, It will also help us identify those rivers that have excessive concentrations and might require additional monitoring. One of the major aspects of this study is to evaluate various factors that can affect sediment chemistry. So as part of this study, we're collecting a lot of ancillary data. We're collecting land use distributions within each basin, covering such things as the amount of agriculture, the amount that's forested, the amount that's urbanized, the amount that's undeveloped, and we're also looking at population density. Previous work has shown that both population density and the amount of urbanization are the strongest or single most important factors in affecting sediment chemistry and also nutrient sediment chemistry. At the end of this project, we will have a series of calculated values that we can compare against the actual measured values in the samples we're collecting. The calculated values will be first baseline values based on Norquat bed sediment samples that were collected at 450 sites around the U.S. The second will be based on worldwide published averages for suspended sediment. The third will be based on land use distributions within each basin. And then the last will be based on population density within each basin. And those calculated values will ultimately be compared against the actual measured values, and hopefully we'll have a better idea of the factors that affect sediment chemistry, and we will actually have values to evaluate those factors against, because we're collecting real samples that we're going to ultimately analyze. It did. Good grief. It also looks like it's empty. Totally clean. It's about 4 feet. I don't think you can hit it with, well, you might be able to hit it with a paddle. Just sand. We'll go downstream about 150, couple hundred yards.
So Art, what do you think the effects of climate change will be on the flux, sediment flux?
Well, the two most significant effects of climate change are going to be temperature changes and changes in precipitation patterns. Precipitation patterns are going to affect the amount of sediment that's being discharged because it's a function of runoff, and temperature changes will affect weathering, which will affect the chemistry of the sediments. So, both effects.
How empty are we here?
Quite empty.
We got sediment this time. Not a lot, but some. I'll take this and take the duplicate, and then we'll go home. Done. The major outcome of this exercise, which will take about 2 years in total, will be to establish a baseline level for off-continent flux against which we can measure subsequent changes and hopefully ascribe them to climate effects or climate change.